This is 20 Minutes of Impact from the United States Energy Association Power Sector Podcast. I'm Herman K. Trabish. I've covered the power sector since 2006, and I currently report for Utility Dive. My guest today is Joe Adiletta, CEO of advanced battery component manufacturer Volexion. Joe's going to explain the technical and market challenges of developing new battery concepts, and he's going to explain why so many miracle battery concepts that you hear about don't work miracles in the marketplace. Joe began his career in batteries with over 20 years at advanced technology companies, including time as product manager with lithium-ion battery maker A123 Systems, before joining Ionic Materials in 2020 to explore the limits of battery storage. After almost 3 years as VP of battery commercialization with battery materials manufacturer Silvatex, he became CEO of Volexion in March 2025. So, Joe, you've said that too often these new battery materials produce terrific results under experimental conditions, but fail to fulfill their promise in the marketplace. So, give us a little background on new battery materials across the spectrum of how they are used. And then tell us, why does this failure happen? And how much potential improvement in battery performance is lost when these things don't get all the way to the market?
Yeah. First of all, Herman, thanks for having me. It's great to be here. I've had, as you mentioned, a long history in batteries. I never thought I'd be on a podcast saying that I love batteries. But batteries technically are extremely fascinating. It's the old sort of onion analogy, right? There's always another layer to peel back and to learn more. I'm not an electrochemist or a battery scientist, by education. So for me, every day is a little bit of a technical learning experience. Your question, battery developments, right? Where are
Yeah.
people focusing on today? The reality is batteries. To the average consumer, you pick it up, pointy end, flat end, right? You put it in a slot and it just works. But it's really an incredibly complex combination of many materials, right? So from an industrial perspective, battery innovation occurs across all of the different materials. That's on the positive side, which is the cathode side of the battery. That's the negative side, which is the anode. Those are the two active materials, right? They're the materials that do the heavy lifting, if you will, and make ions and electrons move around. But then there's innovation across the rest of the cell as well, from the separator, which keeps the two sides apart, aptly named, to the electrolyte, which is the liquid that everything moves through, to all of the inactive materials, conductive carbons that help create electronic networks, to binders, which are basically hot glue that hold everything together, to the foils that underlie them. I mean, it's dozens of different materials that go into a lithium-ion battery, right? And that's not even talking about the manufacturing processes themselves, which is where a lot of the innovation today is focused on, right? Making them faster and cheaper.
Okay, let me ask you something before we move to the second part of that question. Basically, if I understand, in the simplest terms, a battery has all those kinds of materials in it, and they're set up so that electrons flow from, I think it's from the cathode to the anode. Is that correct? To
On
release
on
energy?
on discharge, you would flow from the anode to the
Anode
cathode.
to the cathode. Right.
Yep.
Okay. So
Yep.
anode, and then, and what it simply means is that when all the electrons in that potential inside the battery have flowed from the anode to the cathode, that's when the battery needs to be recharged. It's out of electrons. And it's a very delicate and evolving chemistry to improve the flow of those electrons. Is that correct?
That's right. It is a highly engineered electrochemical system, right? And subtle changes to any of the components can often have desired or undesired effects. So a lot of engineering that goes into something that on its face looks pretty simple and straightforward.
So at a high level, what you're identifying in your new thesis, and we're going to get to that in a minute, is that simply that lots of battery chemistries that sound like great ideas they they don't prove themselves in the marketplace. And at a very high level, before we get to the next question, how would you summarize what is lost that causes that failure of performance?
Well, so I guess I would say that, generally when we're talking about changes to the electrochemical system, right? Large company today, I would say you've got a gulf, right? You've got a whole bunch of small startups, like ours or any number of dozens of others, here in the U.S., Europe, globally, right? And then you've got massive battery companies, right? In China, folks like CATL, BYD. Here in the U.S., you've got folks like our Next Energy, or in Korea, you've got LG and SK and Samsung, and so Tesla, obviously here in the U.S. as well. And so you've got to bridge that gap, right? And that's
Mhm.
really where the hard part is. Innovators, small startups, exceptionally risk tolerant, right? We exist to take risk. Large companies that have to service automotive OEMs at exceptional scale and volume, extremely risk averse, right? So the question is, how do you mate high risk with high need, requirement, or demand for consistent, high quality, repeatable output, right? That's really the question that we have to answer.
Yeah, and so the first question that I want to ask in exploring your thesis is that you've observed that manufacturers reject some advanced materials even when performance in the testing process is improving. What's going on there? Why does that happen? And better yet, what can entrepreneurs understand about that may make them better, more successful in the marketplace? Does it have something to do with what you said, the risk averse big companies not having the patience to wait on these small, risky uh, companies?
Yeah, I mean, that's part of it, right? I think the other part is, um, Ming Chang, who's sort of battery luminary, right? He was the founder of A123, founder of 24M, founder of probably half a dozen other Form Energy, Desktop Metal, a bunch of other companies. Used to talk to students and customers and what have you about the adoption of new battery technologies, right? And he would always say, and I'm going to get the numbers wrong, but paraphrasing here, it's not the 19 requirements out of 20 that you meet that get you into the application. It's the one that you don't that gets you tossed, right? So
Gotcha.
for small battery companies, I think the problem really comes down to, at lab scale, oftentimes things are maybe not easy, but you can demonstrate them in a very controlled environment, right? And that control comes, from materials choices. It comes from the actual testing regimes you're doing. It comes from the equipment you're using. It comes from the scale that you're operating at, right? But it's all very controlled. So then when you start to scale up and you start to think more broadly, right? Startups aren't always paying attention necessarily to throughput and yield and cost curves and existing manufacturing processes and like all of these things. And to go back to what I said earlier, all of these bridges that you effectively have to cross to reach scale, right? So it's really at the end of the day like a risk reward decision, and I think that back in A123 days, for example, the market wasn't as big and a little bit more broadly tolerant of risk, whereas today, right, you want to go out and you want to buy a Tesla, or you want to go out and you want to buy a BMW EV, or a GM Bolt, or what have you. Like that thing's got to be rock solid, right? It's got to be dependable. Battery recalls are exceptionally expensive, right? So again, this idea that you have to bridge this gap of risk tolerance is really really important.
Let me ask you, this may be irrelevant, but I'm going to ask it anyway, Joe. There was a there it there's a problem some time back with some auto electric vehicle batteries heating up. Um, and I just wonder if that's an example of that 20th point being overlooked. that 19 were met, the car was running great, but the 20th point is, or if that's not an example, could you give me one example of that 20th point that gets overlooked?
Yeah, sure. So let me first address the original point. I would say that that is probably not a great example. What I would say it's a great example of is the high level of quality that's required in manufacturing these things, right? Like if you think about old a Tesla that might use smaller cylindrical batteries, they used to have 8,000 individual
Yes.
cells in the vehicle, right? So if you now start talking about 100,000 vehicles or something like that on the road, or 1 million vehicles on the road, you've got 8 billion batteries in there, right? Like your defect level has to be so low because one problem can cause a massive recall
Wow.
and defects, right? So I think that example in particular highlights the level of quality that manufacturers have today, right? Everybody carries around cell phone. I mean, I'm not sure how many lithium ion batteries you probably have right near you, right? I've got two in my ear. I've got one charging. I've got my phone. I've got my mouse. I've got my computer. Right there's half a dozen, maybe 10 just on my desk in front of me,
Yeah,
right?
me too.
And you do hear stories, of course, of people's phones doing this or doing that, but by and large, it's exceptionally rare, right? Given the
Okay.
given the number of cells that are out there.
Okay.
So to answer actually your question,
Uh,
which was what's a good example of maybe not meeting all of
20th.
the requirements, right?
Yeah.
I think that charge rate today is a good example, right? Everybody wants to think about fast charging their vehicle
Right.
batteries, right? For some, we can argue about what the definition of fast charge actually is, right? But if you have an extremely high energy density battery that doesn't charge fast, there may just not be an EV market for that. Like it's great, everybody wants more energy in a tighter space at lower cost, but if it takes you 3 hours to charge it instead of 15 minutes, right, it ends up being a non-starter.
Okay. So I'm yeah, you have some interesting language that you've proposed, and I'm guessing that what you just described might be uh, have applicable one of the phrases that you use. You use the term designing backward from the factory. You call it a survival requirement for battery manufacturers that are introducing advanced materials. Is that an example of designing backward from the factory? You have to know what's at the factory in order to design your products that'll fulfill the need at the factory?
Yeah, I mean, I think that's the charge rate stuff. Maybe not the best example of that, but I think what you're saying or what you're asking is certainly true, right? And that's to say that the product in batteries today, at the end of the day, really is scale, right? Like that's the product. The product is you can make these batteries by the millions or billions, right, at high quality and put them into vehicles, phones, things that we use close to ourselves in our ears, right? Like every day, right? So they've got to be bulletproof, and changes to processes in particular are often more difficult to tolerate. So you've got to understand how things are being made with the end process and work with that in mind. Because if you have to change that process, either process parameters or even worse, like the actual equipment that's being used online, it's just going to take you that much longer. That it'll be that much more costly. It represents that much more risk. So the likelihood of adoption, therefore, becomes much lower.
Yeah. So, and then that becomes more complicated because there are so many different kinds of batteries, I would guess. I mean, the idea of designing backward from the factory for a Duracell battery that goes in my mouse is completely different than designing backward from the factory for the batteries that the power sector is using, or the batteries that Form Energy and Noon Energy are going to use for 100 hours of performance. It's a very different way of thinking for each of those kinds of batteries, but they all have to be, if I'm right, designed backward from the factory. Am I right about that?
Yeah, I think that's a fair statement. Yeah, everybody is choosing a specific electrochemistry. They're choosing an end form factor, if you will, to meet the application requirements. And that form factor electrochemistry may require, to your form energy point, a different manufacturing approach than again, the battery in your phone, or certainly the Duracell battery that you're putting in your TV remote control, right? Which is an entirely different architecture.
And yet, in all at all those levels, there are entrepreneurs out there right now working on grants, working on their parents' life savings, trying to develop new materials that will make those batteries work better, whether it's form energy in 100 hours or noon energy in 100 hours, or whether it's a Duracell. Is that right?
Yeah, that's right. And you know, we are effectively in the midst of an energy transition unlike anything that we've certainly seen in our lifetimes, and likely that our my kids will ever see in theirs, right? The electrification of everything is an eventuality, and we can argue about whether it's going to happen in 3, 5, 10, or 20 years, but at some point electricity is the universal power mechanism, right? And everything is going to have storage and rely on storage. So even the niche markets, quote unquote, in battery land represent tens of billions of dollars of opportunity, right? So
Okay.
there are entrepreneurs that are out to optimize parts and products for those individual segments, for sure.
If you want to hear the big last exchange of this terrific conversation, support the podcast by subscribing at just $2.99 per month to the Power Sector Podcast's Power More. With your subscription, you'll get both parts of the content delivered directly to you the second they drop.